Good evening, everybody, and welcome to another episode of vBrownBag. This week, we are continuing on with our AWS Solutions Architect Professional Certification series. And now, this time, we're talking with Rick Crisci about high-performance computing with AWS. A couple of housekeeping notes before we get started. Feel free to get in on the conversation. Give us a shout out on Twitter at vbrownbag.com, or if you hashtag vbrownbag.com, we will see your questions and we will be able to answer them as we go. Again, our guest this week is Rick Crisci. He is at vrick31 on Twitter, and I am Chris Williams at Mistwire. So without any further ado, let me kick it over to Mr. Crisci. You are the host, sir.
All right. Sounds good. Thanks, Chris.
Thank you.
All right. Well, thanks for joining, everyone. I want to just take a moment to introduce myself. My name is Rick Crisci. I'm a VMware instructor and an AWS instructor as well.
You want to start presenting?
Sure. Yeah. Yeah, let me do that. That's a good idea. Always good to present. So yeah, I'm an AWS instructor and a VMware instructor. I'm also the owner of trainertests.com, which you guys can see here in the background. So what we're going to be doing today is actually a bunch of excerpts from our AWS Solutions Architect professional course that we have at trainertests.com. So that's where most of this content is coming from. And also just want to encourage everybody to feel free to connect with me on LinkedIn as well. If you want to connect up on LinkedIn, I definitely encourage that. And I'm always releasing, more video content and all sorts of stuff on LinkedIn. So feel free.
And it is fantastic stuff, I have to add. I've really been enjoying your series, Rick.
Thanks, Chris. Yeah, I appreciate that. All right. So without any further delay here, let me go ahead and Hey, Chris, just want to make sure, is that control at the top of, are the controls at the top of the screen showing up in the recording here?
They are not, no.
Okay, great. Okay, just wanted to make sure. All right. So we're going to start out here with a concept called loose coupling. And that's really what I want to use to sort of lay the basis for the remainder of what we're going to talk about in our hour here today. So what you see in this diagram is on the far left, we've got a web server. And in the middle, we've got an SQS queue. And on the right, we've got our app servers. And we're going to use the SQS queue in this case to accomplish a design principle called loose coupling. The purpose is I've got web servers on the left, app servers on the right. I want to be able to scale my app servers without acting my web servers. And vice versa. I'd like to be able to scale my web servers horizontally. I'd like to be able to add more web servers, remove web servers without impacting my app servers. And that's what we're shooting for here with this concept of loose coupling, is the ability to scale different tiers of an application without affecting the other tiers. So what we see here on the left is the web server is starting to get an influx of requests. Maybe somebody wants to view the latest vBrownBag session or something. We've got a web server that's hosting it.
Nice.
And so all of these requests are hitting the web server, and the web server is basically creating tasks, right? It's creating these little messages that it's dropping into an SQS queue. Basically saying, hey, app server, this user is requesting this video. This user is requesting this video. And it's the job of the app servers to actually grab those requests and fulfill it. Start streaming the video to that end user. And as that queue fills up with tasks, we start to consider the possibility that my app servers may not have the horsepower to handle that. I might not have enough app servers. They might not be big enough, something along those lines. I may need to scale my app servers in order to make this thing work properly. And that's what having that SQS queue in the middle gives me, is loose coupling. It doesn't matter if there's 20 app servers or one app server on the back end pulling tasks out of that queue. My web server never sees those individual app servers. It doesn't know if there's 1 or 20 of them. right? It just knows that when the web server gets a request, it drops a task in the queue. And so I can use on the back end here an auto-scaling group. Let me grab my marker here. An auto-scaling group with my app servers to say, hey, if the SQSQ reaches a certain threshold, we should do horizontal scaling. More app servers should be added at that time when we start to run into a situation where the SQSQ begins to fill up. And so that's just one example of a way that we can accomplish loose coupling within AWS with an SQSQ. We could use an elastic load balancer as well. It is another very common way to accomplish that loose coupling between application tiers. I could have an ELB here in the middle, spreading out workload to a bunch of app servers as well. But that's really the concept that we want to kind of really have mastered going into this AWS Solutions Architect professional exam, is the benefits of horizontal scaling, right? Creating many instances, automatically scaling in, automatically scaling out, and creating loose coupling so that we can auto scale different tiers of our application whenever it's needed without impacting the other tiers. Okay, so that's kind of just where I want to start us off here, is with an introduction to this concept of loose coupling and what it's going to give us. Oh, and by the way, now you can see my nice little animation here.
Nice.
We've got these we got these 3 app servers that have now kind of gotten spun up and have handled a lot of the workload, right? They basically, we spun up extra app servers, they grabbed all the messages out of that queue, and now the pressure's been relieved, right? So now, if we've got auto scaling configured, we can automatically scale back in, and some of those app servers can now be removed. So that's what we're also looking for here with auto scaling, is elasticity. Right? The amount of resources that are required just happen, right? It automatically scales in when it needs to, and it automatically scales out when it needs to. It's elastic. Kind of like a rubber band. That's what I always think of when I think about that term elastic, right? I can stretch it out bigger if I need to, and I can let it contract back in smaller if I need to. Okay, so how about scaling? Scaling for the front end, and you'll see that this is one of the key items that's referenced on the AWS exam guide, right? And so, if you take a look at the exam guide, part of what the objectives that it walks you through are scaling the front end, scaling the back end databases, scaling the middle tier, how to scale different areas of our multi-tier application. That's a big area of focus for the exam. And so what we're going to do is we're going to start out by just kind of looking at how do we scale the front end first. And so you can see here is I've already got CloudFront as part of my equation here, right? We've got CloudFront in the front. And as many of you probably know, CloudFront is our content delivery network. It's a caching solution. It takes that frequently used data and puts it in these edge locations all over the world so that it can be closer to our users. So that's a big piece of scaling the front end, is using CloudFront, because number one, it's going to deliver content to the users more quickly, but number two, it's going to reduce the workload on whatever the origin is. If it's an S3 bucket, if it's an EC2 web server, it's going to reduce that workload because it's delivering much of the content itself. Right, so that's a big piece of scaling the front end, is having that CloudFront. And then also, of course, we're going to have Route 53. So Route 53 is receiving the DNS request. It is sending that traffic towards CloudFront, right, towards a CloudFront distribution. That's what our Route 53 record looks like. And then any traffic that is not being served up by CloudFront is eventually going to hit whatever we're delivering, whatever our origin is. So here comes traffic that is hitting an external elastic load balancer, a public-facing ELB, where we have web server instances with public IP addresses. And so the traffic hits an external elastic load balancer, and we've got an auto scaling group here for our web server instances so that they can be elastic, just like we talked about in the last slide. Right? We want it to be elastic. We want it to dynamically adjust to those changes in demand. So we'll create an auto scaling group for those web server instances so that whatever the demand of the moment happens to be, they're still going to function according to plan, right? They're still going to provide the required level of service. And then in the middle here, you can see we've got a loose coupling, right? Going back to that term again, loose coupling. So what we've got here is a loose coupling of the web tier and the app server tier, right? Because we've placed an internal elastic load balancer between them. And so we've got this loose coupling. Now the app tier can have its own auto scaling group. The app tier can kind of scale in and out independently of what's going on with the web server instance group, right? So that's kind of the beauty of this design is now either one of my tiers, and I've kind of covered the middle tier here as well, right? Because that's the app server instance. It has the ability to scale up and down without impacting the web tier. So that's what our design goal here is for a scalable infrastructure that's going to kind of consistently meet the needs of whatever the demand happens to be. and then on the back end, we can use things like RDS. We can use things like read replicas and spread the workload out across multiple availability zones or multiple regions. And there's going to be a different vBrownBag session on databases. So I'm not going to get too deep into that. Check that vBrownBag out if you want to learn a little bit about that. Okay. So now let's get into some kind of interesting topics here that are covered on the exam blueprint as well. We've got something called a resource group available within AWS. And so a resource group is essentially a dashboard that allows you to view related resources. Right? Resources like EC2 instances, VPCs, CloudFormation stacks, S3 buckets, all sorts of resources. You might have many resources related to an application. So how do you view all of those related resources at once? Right? And let's take a look at an example. So here on the far left, I've got my end user. And the end user is basically going to access some sort of application that's available on the other side of this elastic load balancer. Right? User's going to launch a session. They're going to hit an ELB. Behind the ELB, I've got an auto scaling group with a bunch of EC2 web servers. Right? And so then, once the request hits the web servers are then sending traffic towards a group of application servers, which are also in an auto scaling group, also behind an elastic load balancer. And on top of that, I've got EBS volumes. I could have, they might be provisioned IOPS, they might be general purpose, whatever the case is. I've got EBS volumes that are going to have a big impact on the performance of that multi-tier application. So right now, I've got ELBs, and there's metrics for ELBs that I want to monitor. I've got auto scaling groups. I've got EC2 instances and EBS volumes, and I really need to monitor all of that, right? And if you think about it, if one piece of this puzzle starts to get slow, starts to have performance issues, like let's say, for example, this elastic load balancer here, the user is going to feel that impact. And how do we take this complex picture and quickly and easily figure out where the problem is? On top of that, we've got a database backend, right, where we're going to have, let's say it's an RDS. Well, that could also be causing a performance impact. Maybe we haven't sized our RDS instance big enough, or maybe we haven't spread out our queries evenly across read replicas. Or maybe the Elasticache is frequently evicting data and it can't keep up with what we've got there happening in RDS. Or maybe we're hosting static web assets in an S3 bucket, right? So now not only is our web server reliant on what's inside of the EBS, the EBS volume, the web server is also reliant on data that's stored in an S3 bucket. And so if any one of these areas starts to have a performance issue, the user is going to feel that impact, right? And it's going to be up to us to isolate that issue, isolate that performance issue, and resolve it. And so what are we going to do? Are we going to go to the ELB dashboard and look at this elastic load balancer? Then go look at this elastic load balancer. Then go to the EC2 dashboard and check all these things out and check out the performance of the EBS volumes. And then if we still haven't had it, are we going to go to all of these different places in the AWS console and try to resolve this issue? That's not really a very efficient approach to make this happen. Right? And so that's the purpose of resource pools, or resource groups. I'm sorry. I went back to my VMware terminology. That's the purpose of these resource groups, is to essentially just give you a dashboard, right? What you'll do, and just a little kind of look behind the scenes here, what you'll do is you'll actually tag these resources, right? You'll assign like a custom tag to these resources. And I'm going to just go ahead and give all of these resources the same tag, like maybe video delivery application or something like that. And based on that tag, they'll be presented on that resource group's dashboard. And the dashboard shows you, any performance issues, all of the kind of problems that you could be potentially running into. It shows it, all of these related resources in a consolidated view. So that's a big benefit of a resource group, is to really cut down on your troubleshooting time and the amount of time that it takes you to analyze the performance of a multi-tier application. So that's resource groups. Yeah, that's resource groups. So that's really the purpose of those. And they're fairly easy to set up. The tagging part is honestly, to me, the part that took me the longest to get done. But yeah,
surprisingly underutilized too, in my experience. I don't think people use them enough, honestly.
Yeah, it's really one of the things you want to think of is, any application that you're deploying in AWS, you want a resource group for it. That way you can just get in. I always kind of say in all my classes, the saying that I probably say the most is an ounce of prevention is worth a pound of cure, right? If you have a problem, you don't want to be figuring out the architecture of your application while that problem is occurring. You want to be able to just get to a dashboard, see what's wrong, fix it fast,
Yep, see what's hollering.
That's the name of the game. All right, so another area of focus on the exam is high performance computing. So with high performance computing, what we're looking at is things like engineering simulations, financial risk analysis, algorithms, molecular dynamics. So those are some of the examples that AWS gives as high performance computing type applications. And so the goal here, of course, with AWS, this is always the goal. You're going to focus on the business needs. You're going to focus on the application. You don't have to focus on building your own high performance compute infrastructure. And so that's sort of always the goal here. With high performance compute, these are applications that require more processor resources, memory resources, IOPS, more network throughput as well, are the things that we're typically looking for with high performance compute. So let's think about this for a moment and just kind of take a look at a little diagram here. And this is kind of like a vendor agnostic diagram, right? Could be AWS, it could be Hyper-V, it could be vSphere. But what we're dealing with here, once we start to get into an AWS environment, we have multiple EC2 instances. Those are just virtual servers, virtual machines, call them what you want. We've got EC2 instances that are running on a physical server, and that physical server has hypervisor software. Right? So allow us to run multiple virtual servers at the same time. So in that situation, if we've got virtual servers that have a memory-intensive application, well, we've got instance types for that. Right? If we've got CPU-intensive applications, we've got instance types for that. And so if I go ahead and let's say that I've got a lot of high-performance compute needs, and I create a bunch of EC2 instances, and I decide I want all these EC2 instances to run on the same physical host. I want to put them together. I want to put them on the same physical host. And the host, let's just assume in this scenario that the host has plenty of resources, right? It's got plenty of memory, plenty of CPU, plenty of network bandwidth and storage bandwidth. It's going to run those EC2 instances just fine. Well, there's a pretty major benefit to then placing those EC2 instances on the same host, because now if they want to communicate, their network traffic doesn't have to go out through a physical network adapter. It doesn't have to hit a physical switch and then get switched back in over a physical network to reach the destination. If I put those EC2 instances on the same physical host, they can communicate directly within the hypervisor. Right? They have the ability to communicate directly at extremely low latency. And so if I have this kind of high performance compute need where I'm going to have multiple nodes running as EC2 instances and they have to work together to accomplish some sort of common task, placing them on the same physical host is going to greatly reduce the network latency between those instances. And so what I could do is I could create something called a cluster placement group. And let me just clear out my drawing here. Create something called a cluster placement group. And with a cluster placement group, what we're doing is we're going to have a bunch of instances. They're going to run in the same availability zone. And what it's going to do is it is going to put those instances as physically close together as possible. So if it can put them all on the same physical host, that's what it's going to do. And so it's going to try and place those instances all on the same physical host, which will give them the ability to communicate with each other directly without that traffic leaving the host. Now, one of the recommendations, and this is the sort of thing that you're probably going to see pop up on the exam, one of the recommendations is that if you want to maximize the effectiveness of a cluster placement group, you should use the same instance type, because different hosts in the AWS data centers run different instance types, right? If you get a C5 instance type, for example, that's one of the latest and greatest, right? The C5 instance for compute intensive workloads. That instance features a certain type of physical processor. So if I create a cluster placement group with a C4 instance and a C5 instance, those instances can't run on the same physical host, because those instance types guarantee a certain type of physical processor. So if I'm creating a cluster placement group, I want to make sure that everything in it has the same instance type in order to keep those instances as physically close together as they can possibly be. We also want to choose an instance type that supports either 10 or 25 gigabit per second connectivity. And as you're looking at the instance types, if you take a look at the compute optimized instance types on the AWS website, it'll shows you exactly, there's a little comparison chart at the bottom where you can see exactly what the different network bandwidth supported by each instance is. So again, this is another recommendation that you might see pop up there on the exam is we want instances that support that high speed network connectivity, and they're recommended for applications that require low network latency. Like if you're doing some sort of calculation on an algorithm and the nodes need to communicate with each other, they're sharing some sort of data or something along those lines. That's the sort of situation where we're going to benefit from a cluster placement group. Okay, so another thing you want to be very comfortable with the exam are the concepts of advanced networking, enhanced networking, and what that means. Instances that support enhanced networking are recommended if you're going to do a cluster placement group so that you can get that better network throughput and guaranteed bandwidth. And you might run into a capacity error. So this is also something that I could see definitely coming up on the exam, the capacity error. So let's think about that for a moment. I'm going to clear out my screen here, my drawing, and I'm going to sneak back a couple slides. So, so if we run into a capacity error, here's what we're doing, right? When we create these cluster placement groups, we're basically focusing in on a certain subset of resources upon which we want to place all these instances, right? So if instances start getting spun up on this physical server, for example, or within this availability zone, and all of a sudden the availability zone is kind of at a point where it's got enough stuff running that it can't handle, another 20 C5 instances, right? That's when you'll run into those capacity errors with provisioning. And it doesn't just happen with a cluster placement group. It can happen with any EC2 instance that you launch at any time. You probably haven't seen it happen a whole lot, but it can happen. So that's what you need to know. When you see these capacity errors that may occur when launching instance in a placement group, what you want to think there is, maybe I'll try it again in 20 minutes. Right? Maybe the resource requirements of the availability zone will be down a little bit later. So what I'll do is, hey, if I'm launching 20 instances and I get a capacity error, I'm going to shut them all down. Right? I'm going to stop all of the instances that did launch, and maybe half an hour later I'll give it another shot. Maybe at that point there will be enough resources within that availability zone for me to launch all of those instances together. And that's really kind of the same recommendation. Even if you're not working with a cluster placement group, if you try and launch some instance and you get those capacity errors, at that point, that's really the best option is to stop them, restart them. And if you're not married to a particular availability zone, then you have some flexibility there. If you launch an instance in a different AZ, you may be able to avoid that capacity error. Okay, let me clear out my annotations one more time. Okay, so that's all well and good, right? Everything we just talked about gives us a pretty nice little laundry list of the benefits of placing our EC2 instances close to each other. Right? The cluster placement group, gave us a number of performance enhancements that are definitely beneficial. However, what we're also doing now is we're saying, hey, put these instances as physically close together as possible, right? So let's say that now I've got all of these EC2 instances running on the same physical host, and that physical host fails. What is the impact on my operation if that occurs? Right? That's the kind of counterpoint that we have to think about with these cluster placement groups. And so what you really need to start to think about now is kind of the same sort of stuff that you think about in a traditional virtual infrastructure. What is the nature of my application? Is it clustered where a bunch of instances are going to be sharing the same data, and it doesn't really matter if they all go down simultaneously? If one of them is down, they're all down sort of scenario. In that case, the cluster placement group is just fine, right? But if you've got something, let's say like, I'm just giving an example that wouldn't necessarily be a high performance compute example, but let's just think about an example we all know about, domain controllers, right? Let's say we're running domain controllers as EC2 instances. Well, I wouldn't want to use a cluster placement group and go ahead and drop, domain controller 1 here on this hypervisor and domain controller 2 on this hypervisor. I don't want that. So traditionally, if you come from a vSphere background, I think a lot of us vBrownBag folks probably do.
We do.
You've used affinity rules, right? Anti-affinity rules. Very similar to what you do in vSphere. You have to think about the same things here, right? The anti-affinity rule is kind of like the vSphere equivalent of what we're going to talk about here. We're going to use something called a spread placement group instead. All right, different words, similar concept. So if you understand an anti-affinity rule, it's very similar to a spread placement group. So a spread placement group can span multiple availability zones, and it eliminates single points of failure. So now you're spreading the application instances out across different physical hardware. And again, let's just go with that real simple example of domain controllers, right? Now we're spreading they're all sharing data, right? All my domain controllers are replicating with each other. But now they're spread out across physical resources so that we don't have a single point of failure. This also supports reserved instances. And so if I've purchased a reserved instance, I can take advantage of that. Right? I can get that lower price point if I launch an instance into a spread placement group or a cluster placement group. Either way, I can take advantage of any reserved instances that I've purchased. And I can save that money there. When you create an auto-scaling group, you'll specify a spread or cluster placement group if you want to. So these are fully compatible with auto-scaling groups as well. Right? If I know I'm going to need a high-performance compute cluster, and I'm going to do a cluster placement group or a spread placement group, I can go ahead and create an auto-scaling group. And as I'm creating it, it'll prompt me if I want to drop these instances into either a spread or a cluster placement group. Both of those are supported with auto-scaling. Okay, so how are we doing on time, Chris? I got a little extra time here.
Oh yeah, you're doing fantastic. We've got another 20 minutes.
Wow. Okay, good. So
if you want to go that far, I mean, it's totally up to you.
No, I'll always talk more. If I have the opportunity to talk more, I love the sound of my own voice, so I'll just keep going.
Oh, we do too.
No, yeah, I was worried because last time I went over, and this time I got some extra time to play with. So
awesome.
So let's use it. So what I just talked about, reserved instances, right? Let's kind of think of, and this is going to kind of go along with really sort of the billing aspect and the cost management aspect of high performance compute, right? Oops, let me go back there. So it's going to really go along with that particular aspect. And of course, the architect exam is very concerned with price, right? Because that's really the big thing with AWS is, you can build an AWS resource that's going to give you all the horsepower, all the performance you would ever need. The real question is, can you do it in a cost-effective manner, right? That's what it all kind of comes down to. And so the beauty of a reserved instance is, and one of the more frequently I found misunderstood features, is when I purchase a reserved instance, basically what I'm doing is I'm entering into an agreement. It's basically an agreement with AWS to purchase resources 24/7. Right? That's all a reserved instance is. You're not purchasing an actual instance. It's not one particular instance that you've got there. You're just saying, hey, I'm going to purchase a C4 large instance 24/7 from here on out. So can you give me a reduced cost? And then of course you can, choose how much you want to pay up front. Do you want to pay nothing up front? Do you want to pay it all up front? If you pay it all up front, your savings are even greater, right? So how does this kind of relate to a couple things? Let's start with the spread placement group. How does this relate to a spread placement group? Well, I can have multiple availability zones, subnets in different availability zones, right? So here we go. I've got, let's call this one AZ1, and this is going to be, a public subnet. And I'm going to call it 10.1.0.0/24. And maybe in availability zone 2, I've created a second public subnet. 10.2.0.0/24. Right? Actually, it wouldn't be that. It would be, let's do 10.1.1.0. Sorry, I got a little messed up with my subnet masks there.
Almost caught you out there.
Yeah, that's my mistake here. Let me fix that. Let me go back here and get rid of this first one that I did. The reason that I made a mistake, in case you're kind of like, what are you talking about, is when you create a VPC, the largest size of your CIDR range is a /16, right? So that's kind of the biggest starting point. So if I'm going to create public subnets within that CIDR range, I can't, have a bunch of /16s. I have to divide up the /16 that is my CIDR domain for my VPC. So this is a more realistic example here. There we go. That's one that I could actually do. So I've got these two public subnets in different availability zones. And if I create a spread placement group, it's going to be firing up, EC2 instances in those different AZs. Right? So maybe it puts instance 1 here, instance 2 over here. It's dropping these EC2 instances in different availability zones to make sure that they don't share any common hardware. Right? My reserved instance that I've purchased can apply to either of those instances. Right? They can apply to any instance running within my account. As a matter of fact, if you set up consolidated billing with AWS organizations, and I know that's a whole separate topic, but if you set that up, your reserved instances can span multiple accounts. Right? And that makes the purchasing and the cost benefit of a reserved instance, that much more powerful. Right? So you can really start to reserve the cost or reduce the costs by understanding, okay, what is my baseline, right? What is my baseline that I'm going to have running all the time? There's a certain number of EC2 instances that I'm going to have running all the time. That's kind of my baseline. And that's the space where I'm going to say, hey, I want reserved instances, right? I know I'm always going to have like at least 20 instances of a certain level running at all times. I'll do those things with reserved instances. If I know, another thing for the high performance computing that I might want to take advantage of is spot instances. If I know that I've got this financial calculations that have to happen at the end of each business day, well, I don't need reserved instances for that. Right? I don't want to pay 24/7 for that. If these things ramp up at, let's say, 8 p.m., run a bunch of intensive calculations, and then they're done, that's a perfect use case for spot instances. And the main thing with spot is what I just want to do is I want to ensure that I've got some kind of, back-end data storage solution. It's S3. It could be DynamoDB, right? It could be any of those options. But I've got to have some kind of back-end storage solution. That's what the spot instances are really doing, right? They're potentially, let's draw an S3 bucket here. My spot instances, let's say their job is to every night I sit in my house all day. I record videos, right? So here's my spot instance application for me personally. I don't actually do this, but let's just say
I was going to ask you, do you actually do that?
no. But let's say that this is what I wanted to do, right? All day I sit in my house, I record videos, and I drop those videos in an S3 bucket. And those videos are in AVI format, right? And when I go to bed at night, I have a bunch of spot instances that fire up. They grab the videos out of the bucket. They pull them in. They transcode them to MP4 format. And then maybe they push them to a different nice durable storage location like S3, a different S3 bucket maybe. Right? This is a perfect use case for spot instances because spot instances come and go. Right? If my bid price is lower than the price of a spot instance at that given moment, my spot instance is gone. I get 2 minutes warning. The metadata of my spot instance is updated to give me that 2-minute warning, but then it's gone. Right? So whatever data that spot instance was processing really needs to be, somewhere that's durable, like an S3 bucket. And so if you, sorry, Chris, go for it.
No, it's okay. It's 2 minutes now. I didn't realize that they had changed the timings on it.
Oh, no worries. No worries. So I'll just kind of wrap this up here pretty quickly, but
no. I meant 2 minute, not 2 minute warning on the video. I meant 2 minute warning on the spot instance.
Yeah,
I didn't realize that the spot instances had a 2 minute warning now. I thought they just yanked it out from underneath you without any by your leave at all.
No, what it does is it actually updates the metadata of the spot instance. So if you have some kind of alerting set up to inform you of those changes in metadata, or if you have like something like, let's say, you've got a task that's partially complete and the metadata gets updated, you can schedule like a log dump or something like that, something that you want that instance to do before it just goes away.
Right. If 2 minute warning, purge everything to S3.
Yep, exactly. Yep. Yeah.
Cool.
Yeah, so that's actually a very common for high performance compute. Spot instances and high performance compute kind of go hand in hand because number one, your savings can be close to 90%. You can get a 90% savings versus on demand by using spot instances. So now you're getting all this super powerful compute capacity at a greatly reduced cost to kind of perform these sorts of things. Right. So that's what we're looking for with Spot is kind of those, batch jobs, those computations that happen overnight, or something along those lines, or, things that we can deal with, instances coming and going. That's the biggest consideration. And then for everything else, we do on demand. Right? On demand is only when we can't get a reserved or a spot to fit the bill, right? Yeah, because on demand is the most expensive. It's the simplest. You can just fire up an on demand instance whenever you want, and you can stop it when you're not using it. So you're not billed when it's stopped. But it's the most expensive per hour, right? So if we have a use case that justifies a reserved instance, let's do that. If we have a use case that justifies spot, let's do that. And for everything else that doesn't fit those use cases, then and only then we will use an on-demand instance.
Yeah, from a this is not exam related, but from a real world perspective, I've noticed that people will do on demand for the POC and the ramp up of an environment, and then once everything is nice and baked in and they know what they need, they'll convert everything over to reserved instances.
Yep. Absolutely. Yep. Yeah.
That way they're only burning as much as they have to.
Yeah, you can save around 60%, per hour by going to a reserved instance. That's kind of a good.
Go to an RI 3-year all up front, you can save 60%, or is it 75? I forget.
Yeah, and you can choose not to get into a whole thing on pricing here, but you can choose either standard or convertible reserved instances. So you can even, if you go with a convertible, you can even change your reserved instance type after the fact, as long as you're going with something more expensive. Is basically what it gives you the ability to do. So yeah.
Cool.
Yeah, and boy, I think that's pretty much covers everything I planned to cover today, and actually a little bit more. I must have talked fast today.
That is fantastic. No, I mean it was so thorough that I didn't have any questions. So I didn't have to stop you along the way to get down into the nitty gritty of anything. That was fantastic, Rick. Thank you very much.
Awesome. Great. Yeah. And just a reminder, everybody, if, feel free to connect with me on LinkedIn. And if you ever want to take a live class with me, my website is trainertests.com. So just visit that and